Hi, today we're going to talk about the addition law of probability. So, suppose there are two events, A and B, in a sample space U, which is our universal set. The event that both A and B occur is going to be notated by the intersection symbol, which is like a upside down U. And it is going to be read as A intersect B. The event that both A or B occur is given by the symbol for union, which is a U. And that is read as A union B. All right. So the addition property of probability states that the probability that A or B, notice when I look at the symbols, I say the word, the probability that A or B is equal to the probability of A plus the probability of B, subtract the probability that A and B happen at the same time. What you need to realize is that if the events are mutually exclusive, then that means that the probability of A and B happening at the same time is going to be 0. Because mutually exclusive means that the events cannot happen at the same time. Another word for mutually exclusive is disjoint, which means they have nothing in common. When we subtract the probability that A and B is going to happen, it is going to keep you from counting things twice. Because remember, the intersection will lie in both circles, and you don't want to count that portion twice. So that's why we subtract it once. So let's look at example 1. A marketing company is doing a household survey. They survey 42 houses and find that 23 households with gas cookers, and then you have 17 households with electric cookers, and 5 who use dual fuel cookers. 7 other houses cook on other cookers. So it says, are G and E mutually exclusive? So that means that are the gas cookers and the electric cookers, are they disjoint? Do they not have anything in common? Your answer here would be no. And that is because you have dual cookers, which means that they have both of them. They can run off gas and electric. All right. So part B says find the probability that you're going to either have a gas or an electric cooker. So what we have to do is we have to add how many gas cookers we have. So if we do that, what we can say is that we have 23 households with gas cookers. So we're going to have 23 plus the total number of homes with electric cookers, which is 17. And remember, there are 5 of them who use dual cookers that have electric and gas. So those 5 dual cookers are actually inside of the 23 gas cookers and the 17 houses with electric cookers. So we have to subtract the 5 because the 5 is in each of the 25 and the 17. And you could verify that, to be honest, by drawing a Venn diagram. So I'm going to draw a small Venn diagram here. So we have gas and then we have electric. We always start in the middle, so we already know we have 5 that are dual. 17 households with electric cookers. Well, 5 of them are dual, but they also are electric. So that means we have 12 electric only. And then if we have 5 dual cookers and 23 households with gas cookers, we would have to do 23 minus 5. And 23 minus 5 is going to give you 18. And then when you add all of them up on the inside, you will get a total of 35 cookers, and they said that you have 42 houses. So 42 minus 35 gives you 7 houses that don't have those type of cookers. They have another type of cooker. So if I want to find the probability that I'm going to have a gas or an electric cooker, I can basically just add 18, 5, and 12. And 18 plus 5 and 12 is 35. However, if I were just to add 23 plus 17, I would get 40 because I would have counted that 5 in the middle twice, because the 5 is in the circle with the gas, because I know 18 plus 5 is the 23. And then I know that the 5 plus the 12 is the 17. So if I add them all up separately, I would have counted it twice. So I know I would have to subtract. So I would know here that I would end up getting a total of, and I have to do, remember I have to do it out of 42. I would have a total of 35 out of 42. And if you want to, you could simplify it, and that will end up giving you 5/6. All right, if we look at example 2, it says a couple had a wedding reception guest list of 175 people. On their reception reservation, 83 people chose chicken, 92 chose beef as their protein for their plate. Let C be the event that a person chose chicken and B be the event that a person chose beef. So the question is asking, are A and B mutually exclusive? The answer would be yes, because anytime you reserve for a reception, you normally choose one meat. There are some times where you can choose more than one meat, but typically they ask you what type of protein you want. So most people, when you reserve a spot for a wedding or some type of fancy dinner, then that is why you only do one meat. So if I say find the probability of A or B, or technically I should be saying find the probability of C or D. So let me erase the C or the D since I'm using chicken and C and B, excuse me, since I'm using chicken and beef. Just to be consistent with the letters, then I can say the probability here would be 83 people who chose chicken, so that's going to be 83 out of 175 plus the 92 out of 175. So when I see that, I will end up getting 83 plus 92. That'll be 175 out of 175. And we know that 175 out of 175 is equal to 1. So that will be the probability that you would choose chicken or beef. All right. Now let's look at independent events. 2 events are independent if one event happening does not affect the other event happening. Okay? So anytime we do this, we would say this is referring to the probability of A and B happening at the same time. Okay? So the probability that that's what that symbol means, and the probability that A and B will be equal to the probability of A times the probability of B. And this will end up happening for two independent events. Let's say if you end up having three independent events, that means that you will have the probability of A and B and C happening at the same time, which means that you would multiply their separate probabilities. So example 1, it says, a coin is tossed and a die is rolled at the same time. The probability of the coin being tossed does not affect the probability of the die being rolled. So they are independent of each other, which means that we should multiply their probabilities. So it says determine the probability of getting a tail and a 5. So the probability of getting a tail and a 5, notice I wrote the symbol when I say the word and, is going to be equal to getting a tail, which is 1/2, times getting a 5, which is going to be 1 out of 6. And when I multiply those two, I end up getting 1/12. Example 2. It says Brandon's riding lawnmower only starts 85% of the time, and his push lawnmower will only start 65% of the time. Use a tree diagram to represent this situation. So the first thing that I'm going to do is I'm going to draw my branches for the riding lawnmower, and it only starts 85% of the time. So we're going to have that the riding lawnmower is going to start up, or the riding lawnmower is not going to start up. And then we have to look at the push lawnmower. So if the riding lawnmower does work, then the push lawnmower has two outcomes. The push lawnmower could work, or the push lawnmower could not work. Notice I'm using R for riding and P for push, and the apostrophe means not. All right, so the riding lawnmower only starts 85% of the time. So that means if I put it as a decimal, that's going to be 0.85. It's not going to start 15% of the time, which is 0.15. The push lawnmower only starts 65% of the time. So where I have the P, I'm going to put 0.65 in both spots. And then that means it's not going to start 35% of the time. And I'm going to put 0.35 there. All right. So now I can find the probabilities. So the probability that both lawnmowers will start, I'm trying to find the probability that the riding lawnmower is going to start, and notice when I say the word and, I drew the symbol, the probability of the push lawnmower is going to start. Neither one of these affect each other, so I'm going to multiply their probabilities. So I'm going to do 0.85 times 0.35, or 0.65, excuse me. And when I multiply that, I end up getting 0.5525. That is the probability. Or we could say 55.25%. The next one, it says he can only use the push mower. So what that means is that we want to find the probability that the riding lawnmower does not start and the push mower starts. So the probability that the riding lawnmower doesn't start is going to be 0.15 times the probability that the push mower is going to start, which is a 0.65. And when we do 0.15 times 0.65, we end up with 0.0975. Or we could put it in percent. And if we put it as a percent, that would be 9.75%. All right, so There are sometimes when there are more than one type of outcome, and that is fine. Okay, so let's go back to our notation. When we have the and symbol, the key when we have the intersection, the key word is going to be and. Okay, and when we have the key word and, our operation is multiplication. If we have the union symbol, the key word for that is or, because remember, it doesn't matter if you're here or here as long as you're a part of it. And the operation here is addition. So let's look at an example here for number 3. So it says Leo spins a 5-sided spinner 2 times. Find the probability that exactly 1, 2 is going to be spun. Okay, so he is spinning a a 5-sided spinner twice. All right, so he wants to find exactly 1, 2. Okay, so if we draw us a tree diagram, we're going to have that on the first spin, he can either spin a 2 or he can not spin a 2. So that's the first spin. And then on the second spin, he can either spin another 2 or not spin another 2. And then, of course, it'll be the same thing for if he doesn't spin a 2 the first time around, but he spins a 2 on the second time around. So it says, find the probability that exactly 1, 2 is spun. So if 1, 2 is spun, that means that on the first one, I want to spin a 2, but on the second one, I don't need to spin a 2. Or on the first one, I could spin a 2. And then on the second one, I can spin a 2. So I can either spin a 2 first and not spin a 2 second, or I can spin anything other than a 2 first and then spin a 2 second. So if I were to write this, I would be able to write it in the form of the probability of spinning a 2 and then not spinning a 2, or the probability of not spinning a 2 and the probability of spinning a 2. So I have 2 different combinations. So what I'm going to do now is I'm going to put my probabilities here. The probability of spinning a 5-sided spinner and you spinning a 2 is going to be 1 out of 5. The probability that you're not going to spin a 2 is going to be 4 out of 5. And it's going to be the same thing for the other one. So I'm going to have 1 out of 5 spinning a 2, 4 out of 5 not spinning a 2. 1 out of 5 spinning a 2, 4 out of 5 not spinning a 2. So what I am trying to do here is I can put my probabilities. So the probability that I'm going to spin a 2 first and then not a 2 second is going to be the probability of 1/5. That's the probability of me spinning a 2 first. And means to multiply. Me not spinning a 2 second, which is going to be 4 over 5. Or that means to add. The probability of not spinning a 2 first is going to be 4 over 5. And means to multiply the probability of me spinning a 2 on the second time, which is 1 over 5. So if I put that in the calculator, I'm going to have alpha y equals, we're going to have 1 over 5 times 4 over 5, which is equal to 4 over 25. So So if I have 4 over 25, then that means I'm going to add it to another 4 over 25 because I'm multiplying the same thing just in reverse order, which is going to end up giving me a total of 8 over 25. So that will be the probability that both of those will happen, or the fact that I will only roll or spin, 1, 2. So if you have any questions, please let me or your teacher know, and you have a great day.